Alright, for this next one, we have to condense the left side of the equal sign. And addition has a relationship with multiplication, so we're going to multiply them. And in case you're wondering how I knew that, you have to follow the rules of exponents. So then I'm going to distribute, and I'm going to get 4y plus 20. Notice that both of them are log base invisible 10, so that means I can cross both of them out. And before you cross them out, just remember it's because I could take 10 to the power of log base 10 and they would cancel. Whatever you do to the left, you do to the right. So then we go back to our equation. 4y plus 20 equals 72. Then you're going to subtract 20 on both sides. Then you're going to divide by 4. And then you're going to take this answer. You're always going to check it up here. And if you put a 13 here, 13 plus 5 is 18. And don't forget, addition means multiplication. So as long as 18 times 4 is 72, then we should be good, which it is. So this is a correct solution. Okay, this one we also have to fix before we equate them. This 3 is a coefficient, which means secretly it used to be an exponent. So I'm going to put log base 7 of 4 to the third power equals log base 7 of 4a minus 8. I'm sorry about my 8. And then since they're both log base 7, I can cross them out. Don't forget, because I take 7 to the power of each side. 4 to the third power is 64. Then we're going to add 8 and get 72. And then we're going to divide by 4 and we'll get 18. Okay? And then don't forget, you take this 18, plug it into the original equation. And so the left side we already know was log base 7 of 4 to the third power, which is 64. And on the right side, it would be log base 7 of 4 times 18 minus 8. So for this problem, we're at the condense again. So subtraction, we're not actually going to subtract. We're going to put the first number mentioned from left as your numerator, your second number as your denominator. We are actually going to divide, because these properties come from properties of exponents. And then if you divide 68 and 4, you'll get 17. Notice both of them are log base 4. That means you could take 4 to the power of both sides, and that means they cancel. 17 equals 3n plus 11. Subtract 11 on both sides, you get 6. Divide by 3 and you'll get 2. And don't forget to always take this 2 and plug it into the original. But I'll tell you for now, it works. Alright, so for number 7, we have to take this 1/2 and put it where it belongs. And that's all. So we have log base 6 of 25 to the 1/2 power, and of log base 6 of the right side. Then here, anything to the 1/2 power is the same thing as taking the square root, so that's how you get 5. Then notice that both of them are log base 6, so I can cancel them. Since I'm running out of space, I won't show you the gigantic 6. Then we get 5 equals 23 minus 4w. Subtract 23 on both sides and you'll get negative 18. And then divide 4 on both sides and you'll get negative 18 divided by negative 4, which is positive 9/2. Don't forget to take your positive 9/2 and check it with the original, but I could tell you it works. Okay, number 8, the last one for this page. We have so many things to do. First, I'm going to take this 2 and put it over here, and at the same time, I'm going to put them as division. So log base 3 of the left side equals log base 3 of 6 to the second power over 4. Then 6 to the second power is 36, and you're going to do 36 divided by 4, which is 9. Then since they're both log base 3, they will go away because we're keeping the scale the same. Add 5 on both sides, and then divide by 2. Make sure you always take this answer and plug it back in because it might be extraneous, but I can tell you right now that it works. So today we're going to do solving log equations. So the steps are to condense first and then solve. And the easiest way to solve is if you have the equation as log of the same base as the other side of the equal sign. And if that happens, the logs can cancel each other out. So you see here I put m equals n. And then after you solve, you must always check for extraneous solutions. A little confusing, but let me show you from scratch. Alright. So this has log base 5, and this has log base 5, and this is fully condensed. That means it's made out of only one thing. And this side is also fully condensed. There's no plus or minus or anything like that on the outside of the parentheses. That means you could take both of these and cancel the logs. And you get 5x plus 9 is equal to 6x. And then you can subtract 5x on both sides. You'll get 9 equals x. And that should be your solution. What we could do is just always plug it back in. And if we're going to plug back in, let me erase my little slashes here. So if I were to plug back in, I'm going to do log base 5. 5 times 9 is 45. 45 plus 9 is going to be 54. And then on this side, we're plugging 9 here. I'm plugging 9 here. 6 times 9 is also 54, and there's no need to evaluate. The left side directly matches the right side, so it is a solution. So you might be wondering, how is this even possible? Well, the correct way of solving logs is to the opposite of log, which is exponent. So I would do, the proper way would be 2 to the power of log base 2 1 minus 4n, and 2 to the power of log base 2 of 2n plus 43. So that means this 2 is huge, and I made the equation into an exponent. Okay, so just to explain to you what I did there. That's why the 2 looks so comically big. Then you can cancel. So you can cancel 2 log base 2 because they are inverses of each other. Then from here you would get 1 minus 4n is equal to 2n plus 43. Then you can add 4 to the right, subtract 43 to the left, divide by 6, and you'll get negative 7. Alright, and then we gotta check this negative 7 by plugging into both sides of the equation. But I do have to erase what I did here so we can see a little clearer. So if I plug it in, I'm going to get log base 2. Okay, if I plug in negative 7 there, that's negative 4 times negative 7 is a positive 28. 1 plus 28 is 29. And then on this side, we got 2 times negative 7, which is negative 14. And then you just got to do 43 minus 14 because they're opposite signs. And you would get 29. And everything seems equal to each other, so we can say that is actually a solution. So now you got the gist. Instead of just crossing them out, you can show that you understand that 9 as a base of a new exponent, the one that I am putting in brackets now, cancels the log base 9. And that's the only reason that you can equate 6 minus 3w equals 2w. You can add 3w to the right, you'll get w, and supposedly 6 will be our answer. So now we'll check it by plugging in 6 on both sides of the equation. Let's see what we get. Okay, so if we plug it back in, we'll get log base 9. And then we'll do 6 minus 3 times 6. And log base 9 of negative 2 times 6. And then our final answer will be log base 9. 6 minus 18 is negative 12. And then on this side, you'll also get negative 12. So you might think this is the correct answer, but actually it's not. It's actually extraneous. And the reason it's extraneous is because you cannot take the log of a negative number here. Not possible. And just in case you're wondering why it's not possible, let's say I took this side, log base 9 of negative 12 equals exponent, and then 9 to the missing exponent equals negative 12, which is not. Alright, so here we are on page 119, and for page 119 we're going to solve log equals a number type questions. So just like in the previous page, you still have to condense and isolate the logarithm. Then we're going to do the opposite of logs and convert them to exponential form. And when you solve, you have to check for extraneous solutions. And don't forget, extraneous solutions happens when they want you to take the log of a negative number. Not possible. Alright, so for number 11, you can see that the log is isolated. That means that there's no plus or minus on the outside here. There's nothing in front here. We are ready to solve this. So what is the opposite of log base 2? The opposite is 2 to the power of log base 2 of anything, because they would cancel each other out. So that is what I'm going to do on both sides. I'm going to put a really big 2 just to show that the 2 is the base, and everything that was already typed becomes an exponent. So, exponent. So then that means that x minus 4 is equal to 2 to the 6th power. 2 to the 6th power, 64. Add 4 on both sides and you get 68. Now before I just put a little check mark there, I do have to check my work. So I'm going to take a 68 and plug it back in, but to the original. So that's going to be log base 2 of 68 minus 4 equals 6. And that is going to be a 64. And don't forget how to convert. The 2 becomes large. You always solve for your exponent and you're evaluating it at 64. And 2 to the 6th power is 64, so your 68 is correct. Alright, let's go to number 12. So number 12, it is not isolated. So you need to take the log and make sure it's all by itself by moving the 7. If I move the 7, all of a sudden, the log of whatever you're evaluating is by itself, and you get a 4. Now you have a 3 here, so that means you're going to do 3 to the power of both sides. And then when you do that, you're going to get 4x plus 8 all by itself, which is what you like, and 3 to the 4th power. 3 to the 4th power is 3 times 3 times 3. It's 4 times. I don't know how many times I said it, and you get 81. Then you subtract 8 on both sides. When you do that, you get a 73. Then divide by 4. X is equal to 73 over 4. And don't forget to plug it back in. But I can tell you right now, it works. Number 13 is all you. You're going to have two answers, and one of them is going to be extraneous. All right, so for number 14, you're going to take this 2 and put it as your exponent. Remember, that was one of your log properties. And then we're going to take that minus and turn it to division. So just so you can see what I'm talking about this minus the properties of exponents means that it will be a quotient equals 2. Then notice that all of these logs don't have a small base. Don't forget that means it was log base 10. And the opposite of log base 10 is 10 to the power of both sides. So I'm writing that 10 big and a base as an exponent. So here you get 10 to the second power, which is 100. Then do the opposite, dividing by 4, which is multiplying. And you get 400. Then take the square root of both sides, and your answer should be x is equal to plus or minus 20. But I'm going to separate your answers because one of them is extraneous. As you might have guessed, it's probably this one, x equals negative 20, and you're correct, because if I start plugging it in, 2 to the log of negative 20, this is already a no-no. You cannot take the log of a negative number. It cannot be evaluated. So that's why negative 20 is extraneous and 20 works. You should always check both your answers. Alright, so now number 15. So for number 15, don't forget addition means multiplication. These are your log and exponent rules. So I'm going to multiply both of those to condense the log. So log base 6 of x squared plus 9x. Then I'm going to do the opposite of log base 6, which is 6 to the power of each side. Then I'm going to go back and I'm going to get x squared plus 9x equals 6 squared, which is 36. Subtract 36 to come on the left side. Two numbers that add to 9 and multiply to negative 36. That is positive 12 and negative 3, which means the final answers are negative 12 and 3. And one of these is probably extraneous, which is this one. But let's check it before I just cross it out. So we're checking this one. And if I just start plugging it in, I don't even have to plug it in the whole way. Log base 6 of negative 12 plus 9, ... You'll see this is a problem because you'll get negative 3, and that's not possible. Therefore, this one's extraneous, and this one's your right answer. And in case you're wondering how I knew it was not possible, the 6 goes here. When you're doing logs, you're always solving for your exponent, and your value at negative 3. Is there any exponent that will turn the original base into a negative? Absolutely not. Now for the last one. Don't forget that addition means multiplication, so we are going to multiply. Then you get x squared minus 3x. Then you have to do the opposite of log, and don't forget if log has no base, it's an invisible 10. So 10 on both sides. And then you get x squared minus 3x equals 10, and if I subtract 10, it will look like this. Two numbers that add up to negative 3 and multiply to negative 10, sorry. That's x minus 5 and x plus 2, which means it's x equals 5 and x equals negative 2. And then we're going to have to check. 5 works. Negative 2 is extraneous, and you can tell even from the very first log of negative 2 minus 3 is going to be log of negative 5, and you cannot do logs of a negative number.